Hello students, welcome all of you. Good morning. As we told in the last class, today we will begin with a new chapter, a new unit whose title is Ocean Energy Conversion System. Okay, Ocean Energy Conversion System. So there are various forms of energy in ocean. Some are visible, some are invisible. So those energy can be very brilliantly, very skillfully can be connected into electricity. Okay, so there are many means, many methods. So in this chapter, we will go through in detail about different such methods by which how ocean energy can be converted into electrical energy. So that is our main theme. And here we will see the first part of the unit is ocean thermal energy conversion devices. OTEC, you can see. So, in which we will see what is the basic physical principle of ocean thermal energy conversion devices. And essentially, there are two methods of ocean energy conversion. So, that is closed system and open system. We will discuss in detail about those two systems. They are very interesting, and such arrangements as systems are installed at many places all over the world. So such examples also we will come across. And in the second part, we will see about ocean tidal energy conversion system. Energy from tides and basic principles of tidal energy. As we know, all of you know what is tides and the neap tides and high tides. So what is the reason for those tides? Such tides are natural phenomena which involves a lot of energy. So these tidal changes can be translated efficiently, skillfully with suitable engineering technique into energy, essentially electrical energy. Okay. So we will come across such methods, tidal energy conversion in another section. And in the third section, we will see ocean wave energy conversion system. So wave is a very common visible phenomena on the ocean surface compared to thermal energy phenomena or tidal energy phenomena, very obviously visible phenomena. You must know that those waves are basically a sort of phenomena which transfer energy from one place to another. Wave is a method to transfer energy from one place to another. So those energy can be very beautifully converted into electrical energy. Wave motion can be suitably applied on certain engineering gadgets, and we can make some motions. Those motion can be properly levered to some generators, and generator can be spun suitably. This spinning motion will lead to production of current. So all these three methods are marvelous engineering technology of the modern era, and which provide electricity to many places all around the world. They are still in the growing stage, but many efforts are being successful. Okay, so we will see one by one, starting with the ocean thermal energy conversion. Okay, that is known as OTEC. Okay, the briefly this acronym is OTEC, and ocean tidal energy conversion system. That is also briefly known as OTEC, but there is a difference in the expansion. And the third one is the OVEC or ocean wave energy conversion system. Separately, we will look into the details, starting with the ocean thermal energy system, conversion system. As we know, the vast ocean, it is exposed to sunlight during daytime. The entire solar energy is getting absorbed by the water in the ocean. So it's a vast collector of solar energy, we can say. So just like the solar panels we studied in the solar energy devices. And very interesting phenomena is that on tropical regions, that means the regions which are closer to the equator, where we get most of the sunlight compared to the other regions, the regions which are closer to the equator, I mean the polar regions. On tropical regions near to the equator, solar radiation is mostly throughout the year it is available. Okay. So where the average temperature is around 20 degrees Celsius up compared to deep water regions which are much below the ocean surface, maybe 500 to 1000 meter down, where temperature will be of the order of few negative degrees Celsius. I mean 0 degrees Celsius, -1 degree, -2 degree, -4 degrees Celsius, like that. Okay, it goes down. So in the upper layers of the ocean, there is temperature 20 to 25 degrees Celsius, where the lower strata of the ocean, temperature is below 0 degrees Celsius. There is a, so that means that there is a hell of difference in the temperature on the top and bottom of the ocean. So this particular difference in temperature can be very skillfully used in certain heat engines to rotate certain turbines. Okay, the temperature difference can be made use in running a heat engine which can in turn spin a turbine to produce electricity. So let us see what is the engineering technique used to convert that heat energy. Okay, so we have a machine. Okay, the machine is an OTEC machine. This is a schematic diagram of such an OTEC device. So this is the region where the working is happening. Actually, there will be some fluid, there will be some liquid, you can say. We will go to the details of the liquid very soon. The liquid is running through these pipes, and here is your turbine, and here is a generator, and you see, as I told you, on the upper layer of the surface, the water is hot. Assuming you take around 27 degrees Celsius. Okay, the hot water is circulated through certain exchanger. Okay, this is what is called an exchanger. And here what happens, the liquid, it is other than water, okay, some other fluid. The details we will see shortly. The fluid will be heated up due to the high temperature. You may see 27 is a high temperature for such liquids. So what happens, those liquids, their boiling point may be some minus -2, -3, -4, like that. Such a liquid will easily boil. Okay, and they form superheated vapor, and that vapor is of high velocity. Okay, whatever vapor, not of course water steam. Okay, some other vapor, high pressure vapor of some other fluids. That will be spinning the turbine here. So after spinning, the steam, that vapor has got cooled down. It is further cooled. It is further cooled by the low temperature water coming from the depth of the ocean. Okay, it is pumped using a motor, and it is circulated here. So that what happens, this vapor, the hot vapor, is cooled further down. After cooling, this become again liquid, and it is again pumped up to the heat exchanger. So this process going on, a circle is going on. So you can see that here we are using both the hot water of the upper surface of the ocean, and we are making use of the cold water from the lower part of the ocean. So both are of use. Upper surface around temperature 27 degree, and the lower surface temperature around -5 degrees Celsius. So these are some of the important data, important ideas. We will again discuss, we'll again explain it very soon. So the thermal OTEC is a process. This all thing we have already discussed. Using temperature difference is made use to heat up either water or some other liquids. Okay. So here you can see that given in a more lively manner with an animation, how this is happening. You have a cooling liquid here. For the time being, let us call it a cooling liquid. What is the liquid? We will see very shortly. This liquid is being made hot and made into vapor form, high pressured vapor form. Then only this will be spinning. How it is made high pressured vapor? By using the hot water from the sea surface. Because during daytime, solar radiation is directly exposed to the liquid water, so water will get high temperature. Just like when you stand nearby to a sea during daytime, you feel very hot. The reason is that the water on the surface get heated up due to solar irradiation. So that hot water is used to heat up the liquid here, and liquid is spinning the turbine, and after the once energy is lost, the liquid energy is lost, it is brought here. This is the second heat exchanger. What is done here? Here what is done is you bring the cold water from the very bottom of the sea, and it is cooled further. Your liquid is cooled further, and after that the hot water is again left back to the upper surface of the sea. Okay, and once it is cooled, the liquid is again pumped to the first heat exchanger. Again it is boiled up and used for rotation of the turbine. So principle is, I hope this is clear. This kind of a device is usually called a closed type OTEC system. Closed OTEC system. Okay, because here the liquid is not open to outside. This liquid, whichever liquid is flowing through, it is not open to the outside world. That is why it is called closed. And there are open system also. We will talk about it later. Okay, so let's have some brief history on it. Actually, all the missions pioneering effort started around 1880, in the year 1880, and it was J. A. Arsonval, a French scientist and physicist, proposed the theory of tapping the thermal energy of the ocean for power generation. So a German engineer essentially. He was both a physicist also. And the real practical OTEC plant was made in the year 1930 by George Claude. He was a physicist actually, thermodynamics physicist. He made the first OTEC plant in 1930 in Cuba, and which could generate around 22 kilowatt of electricity. Okay, it's a major victory at that time. And currently Japan is the major pioneering country who is involved in the development and the engineering of OTEC. They have installed many such plants in different parts of the world. Okay, in 1970, Tokyo Electric Power successfully built and deployed a 100 kilowatt closed cycle OTEC plant in island of Nauru. So Nauru is an isolated island near the continent Australia. It's an isolated island where no other power sources are available, no rivers, no thermal power plant, no nuclear power plant. They depend purely on solar electricity and OTEC electricity. So where Nauru is a very small island near to the Australian continent. So that was the first mission of the Japanese company. And in 2002, India tested a 1 megawatt floating OTEC pilot plant near Tuticorin in Tamil Nadu. And even India today involved very seriously in the OTEC research, in developing new technology in frontiers of OTEC plants, okay, in different parts of Indian continent. And this is a typical view, our exaggerated view of a OTEC system. You can see from deep water, cold water is taken up, and here power generation is carried out by taking surface water. So this kind of a plant usually in sea, that is called offshore OTEC system. And you can have even a onshore OTEC system, where you will take the cold water using long pipes from the depth of the ocean and hot water from the surface of the ocean. Both are made use here in the circulation process. And finally the hot liquid formed is used to rotate turbines in different powerhouses. Okay, the hot fluid will be making use in powerhouses where electricity is generated. So both offshore and onshore plants are existing in different parts of the globe. This is a typical over exaggerated view for better understanding of the OTEC system. Okay, this blue region is entirely the ocean, big ocean, and in fact this is a important idea. There is enough heat in the upper layers of the ocean water to meet mankind's all energy needs hundreds of times over. Okay, so that means that for the entire needs of the mankind can be met with the OTEC energy. In fact, if you properly tap the OTEC energy available all over the ocean, that is enough for all our power requirements. But because of the lacking infrastructure or the problem with the initial investment, people are not taking up such huge projects. But it is a fact that enough energy potential is there for the OTEC plants. So that is the future of the OTEC. And there are essentially two kinds of OTEC plants, as I told you. One is called closed cycle OTEC and other is called open cycle OTEC. In closed cycle OTEC, some high vapor pressure liquids like ammonia is used as a working agent. That is a specialty. Okay, ammonia issue. Earlier I told you that we will discuss in detail about that liquid. The liquid is essentially ammonia. So what is actually ammonia? Ammonia is made up of one molecule of nitrogen and three molecules of hydrogen. Its chemical name is NH3, and it is a highly pungent odor. If you smell it, you will feel very pungent, penetrating like that. So it is not so healthy for human body. And its boiling point is very interesting, minus 33 degrees Celsius. Okay, that is the most key point of ammonia. That means at minus 33 degrees Celsius, the ammonia liquid starts to boil. So you can imagine at 0 degrees Celsius what can happen. It will boil heavily. So when you come to the temperature of 27 degrees Celsius, because ocean water average temperature is around 27 degrees Celsius, as we have seen in previous slide, you can imagine how strongly, ferociously the ammonia liquid will boil and evaporate and form strong, highly pressurized vapor. So this high pressurized ammonia vapor can be used to rotate turbines. Okay, that's the most interesting part. Okay, and of course the ammonia is much lighter than air. So if you expose the ammonia to free air, it will immediately go up because it is lightweight. So because of all these reasons, ammonia is mostly used in the closed type OTEC system. Okay, so ammonia, where it is filled, actually the ammonia will be filled in this chamber. This whole cycle, here it is filled, ammonia is there. Here ammonia will be in the high vapor pressure form. Here ammonia will be in the liquid form. That is the difference. Okay. Keep in mind its boiling point is minus 33 degrees Celsius, very low value. So the entire keep in mind that ammonia is very dangerous, harmful if it is exposed to. Okay. So such plants are usually built with a lot of precautions and care. Otherwise, even a small blast may lead to accidents and other unhappy incidents. Okay. So ammonia or some other low boiling liquid flows around a closed loop at the heart of the system. This is that closed loop. Here is the turbine. Hot water enters through a separate pipe. Here hot water enters like this, and it is boiled heavily and is directed towards the central loop containing the ammonia. Okay, then what happens? Hot water and the ammonia flows past opposite to one another. Hot water is going down and ammonia is going up. So as the ammonia go up, it gets more and more heavily heated up. So the hot water gives up some of this energy to the ammonia and making it boil and vaporize. So you get vaporized ammonia here. The vaporized ammonia flows through a turbine and making it spin to generate electricity. Okay. The turbine spins a generator and converts the energy to electricity. Electricity is carried to the shore by cable. So if it is offshore system, we have to install cable along the underground of the ocean. And if it is onshore, no problem. You can directly feed it into any grid lines. Now, expanded ammonia vapor has given up much of its energy. Okay, after doing work, once ammonia do some work, its energy is lost. So what happens? The hot vapor now convert into liquid, and this liquid is further cooled by this running water. Cooled running water coming from the depth of the ocean. Okay, but it needs to be cooled fully for reuse. Okay, if you want to reuse it, you have to further cool down it and it make perfect liquid. So that is the purpose of this cold water pipe. Okay, so it is run through. So the cold water and ammonia meet in the second is here it is meeting cold water and down going ammonia and up going cold water. They make meets together and ammonia is thereby cooled down. Okay, so this cooled water and now directed into the upper ocean surface. What happens? This cold water is now slightly warm, hot. So you cannot straight away drop into the bottom of the ocean. So it must be dropped at the upper layers of the ocean. Okay, so this is the entire process happening in a closed cycle OTAC system. Very interesting. Used in many running system in many countries. And the second type of system is called open cycle OTAC system. Here we don't use any such ammonia like liquids. Water is used instead, and it's a detailed working we will see in the next class. Okay, so now the time for assignment. Here's the first question. Briefly explain the working principle of a closed cycle OTAC system. Okay, we have explained in detail. You try to write in your own style and language, simplify it as much as possible. Don't simply copy the things written on the slides. You understand the principle thoroughly well, then try to write in your own lines. Okay, that is better for your examination purpose. Otherwise, it will be very difficult to memorize whole thing during your exam. So make it thorough. Try to speak yourself. After speaking yourself, you try to write it all the principle briefly in a A4 sheet. That is enough. You can even make use of this diagram. Here a diagram is given. This is very simple diagram, suitable for examination purpose. Suitable for examination purpose. You can make use it. And here is another question. You may get a short answer question in examination like this. Why ammonia is used as a working fluid in closed cycle OTAC? Why it is used? You can write the properties of ammonia. I have told you. By mentioning this property, then you can explain why ammonia is used as the working fluid in a closed cycle OTAC. Okay, so these are the two questions to be answered and uploaded. So with these comments, let us conclude today's session, and next class we will talk about open cycle OTAC system, how they are working and its working principle. Till then, thank you all. Thank you.